Well, my name is Katelyn Kosar. I'm a PhD student under Dr. Garamani. My topic is a bio-inspired approach to sustainable concrete. Basically, bio-inspired materials are actually already in the industry. They're actually spread out over various fields. Here are just a couple examples. We have gecko feet that are actually influencing the different tapes because of their adhesive qualities. Even in design, they're designed in trains or blades, and this is actually a medical material. So right now I'm focusing on 3 common proteins. These are actually very well-researched proteins. Albumin and lysine are both used in food products. Actually, you've probably eaten them today. And hemoglobin, as you know, is actually found in blood. The reason we chose these is not only are they well-researched and their properties known, is that we were able to test their foaming properties in an alkaline solution. Now, cement is very high pH. It is not very well suited for living situations for these proteins. So we focused on the actual foaming abilities. So basically, we did various tests. Oh, wow, totally missed that. Anyway, we put these into cement to test their changes that they actually made in the cement. For albumin, we actually saw a high increase in the air content. As you can see, it actually went up to 6.5%, which is far greater than a normal cement time. It also basically increased the setting time and decreased the flowability, which actually allowed the air voids made to remain trapped in the cement. Hemoglobin actually was very similar. It had a very high foaming ability, but a very low air content, because the flowing was so high and the setting time was over 30 hours that actually all the air was able to escape. Lysozyme, you can actually see this little middle area where the larger air voids joined together and actually rose to the top, but were actually stuck before the setting time allowed them to rise fully to the surface. Here you can see them in the proteins in the alkaline environment, where it actually lines up fairly decently with the stability capacity of the proteins. So we tested basic tests in these alkaline environments that are well known in distilled water and other materials, and compared them to our results in cement. We're currently working on analyzing the results and finding connections in how we can continue this and test other proteins and test other synthetic polymers and other modifiers in order to eventually work on creating our own bio-inspired admixture based on proteins as a building block. So yeah, that's about it.